And then what do we do? Oh, we got to get rid of this. And then we got to go through this. There we go. And what are we going to do? There we go. And then what are we doing? We are talking about the abacus. When we look, we have the 0. This is 0. This is an abacus. This is a counting tool. This counting tool, and we're going to be learning how to do math. We're going to do 1, 2, 3, 4. How are we doing? Do that. This counting tool, and we're going hello, 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 everybody. So what we're going to do is we're going to read the abacus. Some people want to know how to read the abacus. What we're going to do is we're going to read the abacus. So when the beads are touching this horizontal bar, we do this. That's what 1 is. 1, 2, 3, 4. Notice that we are touching this horizontal bar. This is a horizontal bar. This is the reckoning bar. Reckoning bar. I've never heard of that before, but somebody said it was a reckoning bar, so I'm going to like, okay, it's a reckoning bar. But in abacus world, I think we call it a beam. And so what we're doing is we're reading the abacus. When we read the abacus, we're going to go 1, 2, 3, 4. This is 4, just as we have 1, 2, 3, 4. And then we have 5. The value, let's see, 5. Nope, that's not it either. Here we are, 5. So if you notice, the 5 will always be the top bead. When I clear my abacus and I do this, this is the top bead. The top bead is 5. That is always going to be 5, no matter what. This is always 5. So then we add 5, and then we have 1. How do I know this is 1? Well, remember when we talked about it, this is 1, 2, 3, 4. And then when we add the 5 from the top bead and we add the 1, now we have 6. Now we can actually decompose. We have 6, and then we have 7. Notice we have 7. Okay, sorry. So then what I could do is this. Yes! Cool. So when we look at it, we have 5, 6, 7, 8, 9. And then we have 10. That looks very familiar. Yes, 10 looks very familiar because that looks like 10. And then this is 10. No, this is 1. This is 10. This is 100. And then this is 1,000. And this is 10,000. How do we know? Because when where is my little paper. Let me talk about it. I need to find that's not what I'm looking for. I'm looking for something. What am I looking for? Oh, here it is. So when we're labeling it. We have our there we go. Much better. So what we're going to do is we're going to label. We label. So this is a ones, tens, hundred, thousands, 10,000s. We're reading the abacus. We're just going to read numbers. We're going to read a bunch of numbers. So we go 1, 2, 3, 4, and then 5. Because we have 5, then we have 6, 7, 8, 9, and then 10. Notice when we write 10, it's a 1 and a 0. So when we write 10, it looks very similar to how we write 1 and a 0. So when we write it, right, it's a 0, this is 0, and that's a 1. Does that make sense? I hope that makes sense. So when we look, now we can count by tens. 10, 20, 30, 40, and then 50. All the top bead has a value of 5. 50, 60, 70, 80, 90, and then we have 100. 100. When we label our columns, because each column is a place value, we have our ones, our tens, our hundreds, our thousands, our 10,000. Hello, everybody. Hello, welcome. Let me know if you have any questions. So if I did this on my abacus, what number do we think that is? Please put it in the chat what number you think that is. And then we can continue on. Because the idea is to learn how to read the abacus, and then what we're going to do is we will learn how to add, subtract, multiply, and divide, but it all depends on how far we get. So, yes, thank you, Morgan. Thank you. So I'm not the only one. 10,000. 10,000's over here. Thank you very much, J-Bug. So yes, it is 3. Thank you. Perfect cell. So when we look, it's 1, 2, 3, 4. Easy, right? Simple to use, easy to understand. When we have 4, because it's touching this horizontal bar, this is 4. Now we have 5, right? Does that make sense? This is 5. This will always be 5 no matter what. This is 5. All of these are 5. So anytime that these are touching like that, this is all considered 5. So when we clear it, and I did this, this would be 50. Ah, good. Thank you, Morgan. Thank you so much for commenting. Now I don't feel so alone. So when we're adding, right, when we add 1, so we have 5 and we add the 1, now we have 6. And that is what we're trying to do, is we're trying to show what the number 6 is. Here is 6. Sometimes it's easier to see what 6 is. So on my abacus, when I show you what 6 is, that's what 6 looks like. And then what does 7 look like? 7 has this 5, 6, 7, 5 bead, the 5 bead, the value of 5, and then the 2 beads here. So 5 plus 2 is 7. And then we have 8, we have 9. And then after 9, well, what's after 9? We have 10. 10 looks like this. And then when I line it up, it has like that. So, anybody have any questions? What are some of the questions you might be having? Does the colors matter? No, the colors don't matter, because when you get into a bigger abacus like this is a 13 column abacus. And because it's a 13 column abacus, it doesn't matter. It doesn't matter what the colors are, because they're all brown. I'm going to find you. Oh, that's good. I hope you find me, because you did find me. You're here. So when we look, we have 1, 2, 3, 4. Notice it's exactly the same. When we have 1, 2, 3, 4, right? Does that make sense? So when we look, we have 5. Every top bead is a value of 5. So it doesn't really matter um what the colors are, right? Tell chat about how I what? Ha ha ha! You're so funny. That's too bad. Okay, so spam submit. So what's going to happen is we have our 5, we have our 5. So when we do 6, that's what 6 looks like. And then we have 7, and then we have 7, and then we have 8, and then we have 8. And then we have 9, we have 9. Notice the colors doesn't make any it doesn't matter what the colors are. Does that make sense? So what we're trying to do is to show you, what I'm trying to do is I'm trying to show you what does it mean to look on the abacus. When we have the beads touching this horizontal bar, right? That is what means that it's being counted. Oh, you look like an old person. Oh, that's too bad. Oh, that's too bad. Report account. There we go. Okay, so does anybody have any questions? Anybody have any questions? Okay, so what do we have? Okay, when we do, right, we have 9 and we have 9. So thank you so much for the hearts. We're going to count again just to revert. What is 1? Hey, thank you, blue-eyed Johnny. 1 looks like this. So 1 is like that. The reason why is because we have the 1 bead. When we look, hi, bar. Yes, yes. So when the beads are touching this bar, is there an abacus in my foster home? Oh, yeah. I've always been very curious. Oh, that's fantastic. So I have a question. With the abacus that's inside your home, is a 4 bead on the bottom and 1 bead on top, or is it 5 beads on the bottom? And so what does your abacus look like? So what does 27 look like? So let's look at 27. When I look at 20, this is 20. How do I know that this is 20? Because I'm going to have my tens. So this is 20, and then I have 7. 5, 6, 7. That's what 27 looks like. Thank you, Kingster. So Bear, if you want to, let me know what your abacus looks like, and I can tell you how to. It can tell you what we can do with it. So then we have 27, and then if you notice, Kingster has a number in the name, right? You have 6. You have 6,651. That's what 600. So the blue bead represents 5. Yes, exactly, Nixon. So the blue bead is the value of 5. So when we look, we have 5, 6, 7, 8, 9. Notice when I count it, we have 1, and then we add the 5. Now we have 6. We have 2, then we have 5, and then we have 7. If I have 3, then we had 5, we have 8. We have 4, this is 4. We add the 5, right? Now we have 9. I love this. Oh, thank you so much. I'm so happy. I'm so happy because, some people are stalkers and spammers. I'm happy you're not one. Hi, Sincere. Welcome. Welcome, Sincere. Okay, so thank you. I do appreciate everybody commenting. So, Bear, what kind of abacus do you have? And so when we look, let me know, Kingster, what is another number you wanted to see? So, oh, there's another one, Snake Eyes. Snake Eyes 52. It goes to decimal place. This one specifically in here. Oh, here, Blue Eyed Johnny. That's a good one. This one, if I said that this is my ones, then I have 2 decimal places. That's a really good observation. Hey, Nora, good. Welcome, welcome, welcome. So, but the other thing is, Blue Eye, is if I chose this one to be my decimal place, like a little Pokemon, I chose this one to be my ones, I'm going to move everything over like this. So if you notice, I have my ones, my tens, and then I have no more hundreds, but now I have all of these to be my decimal place. So if you really wanted to, you can have all of these numbers as your decimal place. So it could be a really, 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 really small number. Ah, Kingston. Yes, Kingster. Thank you. So we have 900, we have 900, this is 900, and then this is 12, 1, 2, and then we have our decimal places, 32. Make sense? So what we're doing is we're learning how to read the abacus. I'm going to move my labels so it matches a little bit. So we have our ones, our tens, our hundreds, our thousands, our 10,000. And then we have tenths and hundredths. So this specifically has tenths and hundreds because I chose this one. However, if I choose this one, oh, where are we? We're over here. Euro, and now I'm mesmerized. Thank you, Troubling. I'm very happy you're here. Thank you for joining me. So what we're going to do is we're going to count the abacus again. So now if I choose this one to be my ones, because I have my dot indicator, if you look at my dot indicator, I'm right here, right? These are my dot indicators. But my Pokemon, I'm going to choose this one. I'm going to choose Pikachu right here. Oh, Chaz, that's fantastic. So we have 1, 2, 3, 4. Because we have a value of 4 touching this horizontal bar. Okay, does that make sense? Anytime these beads are touching the horizontal bar, we're counting it. Yeah, I cannot thank you enough. This is amazing. Oh, this is fantastic. I'm so happy. So this is 0. None of the beads are touching the horizontal bar. Now we have this. This is 5. All the top beat is a value of 5. My Pokemon, you're so fun. Oh, thank you. Thank you. I appreciate that. So I got jokes. I got jokes, but we got to keep going. So we have 5 and we have 6. 5, 6. 1, this is the 5 and we have 1. We have 5 plus 1 is equal to 6. We have this one that's 2. 5 plus 2 is 7. 5 plus 3, right? 1, 2, 3 is 8. 5 plus 4, 1, 2, 1, 2, 3, 4 is 9. So anytime we do this, this is all 9. But I chose this to be my ones. This will be my decimals. So my tenths, my hundredths, my thousandths, my 10,000ths. So what do we do? How do we do abacus with basic math? We can do it, however. Oh, good, Chaz. However, what we need to do, and that's a really good question, Kingster, is we got to understand how to move the beads first. I'm going to make a note of this question because we can answer it after we know a few things. What are the few things we need to understand? Well, there's a few things we need to understand, but let me write down the question. 36. So the first thing we're going to do is understand how to move the beads, okay? So I showed you how to count, which is not a problem, right? Now we know how to count. Okay, good. Hello, Spooky. Welcome. Thank you for the follow. So the first thing we're going to do is understand that if you notice that the beads there's a ridge, there's an edge, and it's not delicate, but it's gentle. So moving the beads is very gentle. You don't need to be very aggressive. Hey, welcome back, Mr. Clean. So what we're doing is we're learning how to move the beads gently with our fingers. And if you notice, I have the ridge. And so with the ridge, that's what you're going to do is the ridge, the edge of the beads to move the beads, right? Does that make sense? So what we're going to do is understand that when I move the beads, it's gentle. So if I knew this, and then just like Zeus in Thor, was it Love and Thunder? If you flick too hard, then your numbers will get messed up. Hello, Neon Panther. Good morning, good evening, good afternoon. So if you notice, first time in the morning, no, I've been in the morning for a few times. Before I forget, so what's going to happen is if you flick too hard, you'll notice that your numbers get all messed up. Oh, for you, yeah, it is. So notice, right? That you don't want to flick too hard. I love when someone is passionate about what they teach. Oh, thank you, Kingster. I have a question. Yes, about multiplication. Can you answer it when you're done with explaining this topic? You know what? I know you're on a time schedule. Mr. Clean, let me know what your question is and we can do it on the abacus. And then we'll come back for everybody else to understand. Is that okay? So if everybody's okay with we're just watching what multiplication is. Give me your question. And then we'll go back and I'll start going into the adding and subtracting. So what we're going to do is we know how to move the beads. We're going to continue on moving the beads, right? So we're going to have 1 plus 1 and then 2. What I want to do is I want to move the 2 beads, right? So that's what we're doing. So while I wait for Mr. Clean's question, we will continue on how to move the beads. So we understand how the beads are, right? We're understanding how what the beads look like. We're going to start going into adding moving the beads. So this is a book that I'm gotta reorder. I gotta reorder this, and I'm really quite excited. The first thing we're gonna do is we are gonna understand that in abacus world we look at excuse me, we look at the added, right? We only look at the added. We don't look at the result. So if that makes sense, why are we doing that? Because in mainstream math, there's always the focus on the result. But what do? We have to divorce the result, marry the process. Ah, I was trying to do double digit multiplication like and I got the answer wrong. Yeah, what is the question? Let me know what the question is. Give me any question you want. Give me a question that you are working on, and we will go through it slowly. So here is 5. When I add the 5, you'll notice 26 times. Okay. You'll notice that when I add the 1, I add the 1, right? When you notice I have 6 and I want to add the 1, I'm only adding 1 bead. And again, you'll notice I'm only moving the 1 bead. Okay, so Mr. Clean gave me a question. Let me do that really quickly and we'll go back to moving the beads. Here is the question. So this is a 4-digit question. So the first thing we're going to do is understand, Mr. Clean, that we're going to count our digits. How many digits do we have? 4 digits. Thank you, Neon Panther. 1, 2, 3, 4. We're going to count our digits. The reason why we're going to count our digits is so then we know where to place the answers on our, thank you, Mr. Clean, on our abacus, right? And so what we do is we go from left to right. 1, 2, 3, 4 is where I'm going to start with my answer. So what I'm going to do is I'm going to go left to right. Does that make sense? I need it. Can you do, yeah, I could do that too later. Let's do, okay, 798 times that 1965. All right. So I'm mainly disappointed in myself that I never exposed using the abacus until now. Okay, so what we're going to do, Mr. Clean, is 2 times 1, right? We understand 2 times 1 is equal to 2. When 2 times 1 is equal to 2, what is this? This is a single digit. So you actually have to go back one column and you have to add the 2. Does that make sense, Mr. Clean? The reason why is because we want to try to make it a 2-digit number. Just like how we do, um, like a 2-digit month, 2 digit. Yes, we go back one column for single digits. Yes, exactly. So the next thing we're going to do is 2 times 7. 2 times 7 is equal to 14, right? Oh, sorry, 14. So 14, we add the 1, we add the 4. Okay, we're done. We're done with this number. So we don't need to look at it anymore. Now what we need to do is we need to count again. So when we count again, how many digits do I have left? How many digits do I have left, Mr. Clean? How many digits do I have left? Yes, thank you, Neon Panther. Yes, thank you, Mr. Clean. So I have 3. 1, 2, 3. So I'm going to count. 1, sorry, 1, 2, 3. So now I'm over here. The question is 6 times 1. What do we do with 6 times 1? 6 times 1 is 6. What do we do? Yes, 0, 6. So we're going to go back one column. We have a 6, right? Thank you. Mr. Clean, does that make sense? We go back one column, we add the 6. Can we add the 6? Can we do it? No, we can't. So what do we do? What do we do? If we cannot add the 6, what do we do? Plus the 10 minus the 4. Mr. Clean, did you understand that? When we, thank you, good. Plus the 10 minus the 4. That's how we add the 6. Then what do we do? 6 times 4, 6 times 7, 6 times 7 is what? 42. 42. So I had my 4, I had my 2. So my final answer is 442. Math's always been the hardest for me. I'm glad these people are teaching it for free online. Oh yeah. Yep. Mr. Clean, did that make sense? So when we added, but see the thing is it's right here, right? Right here is when we had our little bit. Why? Because we had to use our plus tens. Yeah. Yeah. So take it one step at a time. Take it one number at a time. Don't go too far ahead and don't go too far back. Yeah? Okay. Somebody had this question. Do we want to do this now or do we want to do it later? Because there's more, there's foundational pieces that needs to happen before I go to here. That makes a lot of sense now. Yeah. Good, Mr. Clean. I'm so happy you had that question. Let me know if you have any more. Let me know if you have any more multiplication questions, and we can break it down. Yeah, not a problem, Mr. Clean. Thank you. I know you're on a time limit. That's why I want to get it out the door because I know you're okay. Let's go back to the basics. Yes, good. Thank you, Kingster. Thank you. I will. Yes. So what we're gonna do is that was a little bit right to understand that you can do multiplication on the abacus. So again, the first thing we're gonna do. Oh, you know what? Let's take it one more step. You know what I did is I have this thing where we can read the maze. So I have a maze, and this maze is to tell us how to. Where is this? There we go. So what we could do is we could do some bead recognition, and this is for the seven spaces one. What about it? What about it, Neon? What number do we think this is? So this is about bead recognition, and what I've done is I have a book. Right now, I have a book, and what we can do is we can look at the this is about two digits, and this is only talking about two digits. However, what we can do is we can do three digits, right? And I'm actually in the process of making a three-digit puzzle book. And what it is it's a bunch of puzzles. There's I think there are 14 puzzles. And what we do is we just kind of go through and understand how to read the abacus. You start from, let's see, you start from here, you read what the abacus is. So this is 49, and then we can go up to here, right? So that's what we're going to do. So Mr. Clean says 800 04. Yes, good. 800 04. Does that make sense? Kingster, does that make sense? How do I do 800 04? So we do 800 04. Yes, they. Oh, good, Kingster. Good. So we have 5, 6, 7, 8, and then we have 1, 2, 3, 4. Does that make sense? Zeal, are you okay? Are we all right? So the answer was 800 04. So my next number would be this. Yeah. Yes. The top bead is yes. The top bead is 5 plus the 3. Yes, and that's how you get 8. So here's another question, and what we're doing is we are just learning how to read the abacus, right? There's steps and we need to do is we need to understand the fundamentals. So the first thing we're going to do is understand how to read the abacus, because if you don't know how to read the abacus, then it's very difficult to to do any math. Yes. 4, 1, 2, 3, 4. 1, 2, 3. Yep. 434. 1, 2, 3, 4. I am so happy Zeal gets it, right? You get it, Zeal? Thank you, Sincere. Thank you, Sincere. So what we're going to do is we're going to follow that, and then this is my next question. So when we look, oh, maybe I move it over this way. There we go. There we go. So we have this number, we have this number, and then we have this number. What number? It would be impossible to do math if you can't read it. Yeah. Hey, CompuBear. Yes, good. Fantastic. I'm so happy. Okay, so we have, what number is this? If this is the that's this, and then there's this. Oh my gosh. Oh my gosh. Oh, I think I did this one. I used this one. Yes, you're right. 700, 5, 6, 7, and then 9. 5, 6, 7, 8, 9, and then 5, 6, 7. So we have 797. Thank you guys. Thank you guys for commenting. Now I don't feel so alone. 700. Uh-oh. 700. Oh, I did this one wrong. I got to redo this one because it's supposed to be 8. That's not 8. I don't have a number here. Thank you guys. I have to go back and I have to edit my stuff. Okay. So we have, I think it's going to be this number, but that's okay. We have this number. What number is this? That one, this one, and then that one. Thank you, Neon. Yes. That Asian kid, yes. CompuBear, yes. Kingster, yes. Fantastic. Hey, Blue, Mr. Clean, Sincere, good, good. Trouble, yes, good. Zeal, good. Alex, not quite, because we need to have the zero. Oh, good. It was a typo. It was a typo. Okay, so we're over here, and then we come down here, it's the 903. So then we have this one, right? So this is my next book that I'm coming out. And so what I'm doing is I'm just building out my mazes, and I'm making sure that it is all. Oh, see? That's a duplicate. Oh, that's a duplicate. That's a duplicate. I don't like this one so much. Oh, thank you. No, yep, 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 yep. So we have that one and it goes over here. Oh, okay. So I have to change this one. This one I have to modify. Modify. All right. We have this one. We have this. And we have that. What number is that? Yeah, I'm so lost. Mari, what we're doing is we're trying to learn how to read the abacus. So the first thing we're going to do, thank you, that Asian kid. What we're going to do is we're going to understand. Oh, good, bear. Good, good, good. So what we're going to do is understand this is three. One, two, three. Mari, are you still here? And then yes, Zeal. That's exactly right. Four. One, two, three, four. And then we have six. Five, six. Can you explain how the abacus works? We're doing it right now. So what we're going to do, does that make sense? When we look at it, well, everybody, okay, wait, I'm sorry. Let's do this. It goes over here. Okay. So while everybody is working on this, here is a review on how to read the abacus. So So what we're going to do is we understand how to read the abacus. Every bead that touches this horizontal bar is being counted. So when we look, we have one, two, three, four, and then we have five. The value, the top bead will always be five. So we have five, and then we have six, we have seven, we have eight, we have nine. Thank you guys, Neon, Kingster, and Zeal. So when we look at it, this is nine. Bagel. This is so helpful, interesting. I've always wanted to know how to use the abacus. Yes, thank you. Good, good, Blue Bear. I showed off my abacus to my friends. I think I'm the next Einstein. Mr. Clee, that's so funny. So what number is this? This is nine. We have nine. We have one. And then we have six. Does that make sense? Oh, good, Mari, you're still here. I'm so happy. So what this is if you look, why do we do this? Is because we have place values. Every column is a place value. So if you notice, just as we have numbers, right? We have 916. The ones, the tens, the hundreds, the thousands, the 10,000. I'm going to get an abacus just to show my friends I learned how to use the abacus on TikTok. That's fantastic. That's fantastic. So, Mari, as we go through, what we're doing is we're learning how to read a three-digit abacus. So that means it's the hundreds, the tens, and the ones. So if I look at this, that's the number, and then we have this and this. What number do we think that is? Thank you, Neon. Thank you, Asian. Does dividing work on the abacus? Yes. That Asian kid? Yes. We can do division on the abacus. Blue Bear, Comfy Bear, and Mari. Thank you, Mari. Bright. Welcome, Bright. Sandman, almost Sandman. 900 is this. That's what 944 would be. 944. But you're very close. So when we look, Sandman, we want to make sure that only the top beat is touching. We have to make sure that the horizontal bar is the only ones that's counting the digits. Does that make sense? So this is 400, 599. Okay, so we're back to here. Now we're back to here. Is this tricky? This is not tricky. This is not tricky at all. Oh, good. Yeah. See, and that's the interesting thing about the abacus is that it provides you a skill for attention to detail. Yes, good. How do I know? Because this is zero, so there's no number here. This is a zero. And I do this. This is one. And then we have this, six. Yes, thank you, Simon. But sometimes we don't need to have a zero in the front. We can just have 16. I've seen the abacus in different sizes. Do you know when you need the bigger one? I'm 61 and I learned how to use the abacus. Yeah. Zeal. Yeah. So zeal as well. We don't need to say zero, right? Because we're not trying to make a three-digit number. But when we do two digits, we want to make it in a two-digit number. I don't know if that made sense. So the different sizes of the abacus, it just means that you have more digits to do numbers. So if I have this one and this is a 13 column abacus, the only thing is it works exactly the same. It just means that I have more digits. So this is 16 and now we're here. So if I go here, right? And I like to use this Pokemon. I like to use this Pikachu right here. Pikachu will be right here. This is my ones place. And I'm going to do my nine. Oh, that's not it. I'm going to do here. That's my that and then that. So when I have it, thank you very much. Oh, thank you, Blue Bear. No, not a problem, Bear. I'm happy that you enjoy this. I'm happy. I'm very happy. I'm happy that you're excited about this. But yeah, let me know if you have any other questions. Thank you so much for the heart me. 94. Thank you, Mari. Yes. How do I know it's 94? So when we look at it, it's 94. And that if I really wanted to, right, I could use this as my ones place. So I would just move everything over and I'd be like 94. It doesn't matter. This might be the most excited I've been about math since second grade. Could you just count up to 10? Oh, yeah, not a problem, Cody. So let me go back to my colorful abacus, and it'll be easy. I can't believe I learned it so fast. Yes. So, Cody, when we look at it, 1, 2, 3, 4, and then 5. Because this is 5, we have 6, 7, 8, 9. And then after 9, we have 10. That looks very familiar, doesn't it? That looks very familiar as this. Hi, Null. But notice when I show you the labeling, we have tens, ones, tens, hundreds, thousands, 10,000. So when I do 10, 0, 1, the dot, yes. Thank you, Null. The dot is the ones place, but you get to choose which one you want, just like a Pokemon, right? I choose this Pokemon to be whatever, fighting whatever, right? It'd be the same thing with the dots. So you could choose this one, or you could choose this one. It doesn't really matter. Any one you could choose. So, Cody, did that make sense? So now we can count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90. After 90, we can do 100. 100, 100, 100, 200, 300, 400, 500, and then 600, 700, 800, 900. Do you teach offline? I do teach offline. And I have workbooks. I made all these workbooks. I have a lot of workbooks all about the abacus. So that's one workbook. I have this workbook. We're going to go through some of my workbooks. And I have this one, which we're going to start going into this one plus how to buy. Where can you buy them? Where can you buy the workbooks? You can either buy it from my TikTok shop because I'm trying to build out my TikTok shop, or you can find my workbooks here. And my name is Lynette. Welcome. Hello. Charlie, she's been teaching for about 20 years. Yeah. Yeah. Um, if you're looking for worksheets, I do have some available here or on my website. Ah, hello, that Asian kid. Yes, hello. Thank you. No, thank you. I appreciate it. So, I do sell the abacus as well on my TikTok shop. And what do I do? Oh, and I'm trying to build out my TikTok shop. So I have to bring in some orders for the preschool. So if you're looking for um preschool stuff. The reason why it's preschool is because it's a little bit more it's a little bit more um there's a little bit more activities with the numbers and stuff. Thank you so much for the share. And so this is about bead recognition. And so I mean for adults we don't need to know how to do this, but this is like pixel art. So the idea was like understanding what the number looks like and then coloring it in and then you get a pixel picture. So the idea here was to start the kids young. I wanted to start the kids young. Oh, I want to teach my nephew. He's 6. Oh, that's perfect. So you could start with this one if you wanted to. But 6 is a little bit older. I would, if you wanted to, you could start him with this one and get him to understand how to read the beats. You could have him start with a 2-digit maze and get him to feel good about it. I'm having a blast doing this. Oh yeah. Oh yeah. I have a couple of people that bought this one here is available. Right now it's at a I have it as a discount over here. Right now and I think in next month I'm going to raise the prices. But for right now it's at a really cheap discount. It's like $7 and it's going to be 14 mazes. Oh yeah, there's 14 mazes and then there's answer sheets in the back. And this is to just recognize what the numbers are. And what I did is here is what we call a reverse maze. So the idea was if you start here, you need to color in the number you see. So here, so yeah, I think that for a 6-year-old, understanding place value, I think would be a perfect start. Just to get him to understand. So this is a reverse maze. So you know that this is 68. You would have to color in 60 and then 8. 5, 6, 7, 8. And then if you go up to here, right, that's how you go. And then you know that the number is 24. So you have to color in 20. Oh, sorry, that's wrong. I got to color in 20, right? And then I color in 4. 1, 2, 3, 4. And then we go down here. This one is my first edition, and there's a little bit of a typo, but you should get one without the beads on top and without the beads on the bottom. Oh, the 2 beads on the top, does that work? It does, but you know what? This was a template that I had, and you could do it with a Chinese abacus. So let me show you what a Chinese abacus look like. When this is what a Chinese abacus look like, and it works exactly this. It works very similar. Kingster, Miss, I appreciate your love and thank you for teaching me this. Oh, cool, Kingster. I hope to see you soon. I hope to see you in my next live. Thank you for joining. I always assumed you had to have superpowers to read that. No, Seal, you're so funny. So we have this is the Chinese abacus, this is the Japanese abacus, right? And so what we're doing is we're going to learn how to read the Chinese abacus. Does it matter? It doesn't really matter. You still need to understand formulas. We still need to go into how to add and subtract. But the first thing, thank you so much for that flower headband. So the first thing we're going to do, this is just extra knowledge. So we're going to count on the Chinese abacus, 1, 2, 3, 4, 5. Notice when I have 5, I have to do a trade it in. I'm going to trade it in for the top beat. The top beat still is the value of 5. And then we have 6, 7, 8, 9, 10. 10, I'm going to trade it in from this 5, I'm going to trade it into the top beat. So now I have 10. After 10, because I have this, I'm going to trade it in for this one. So now we're back to something that doesn't break my brain. So what's going to happen is we just do 11, 12, 13, 14, 15. That's it. So that's how we do the 2 beads on top. This one just happens to be the way this was. I realized that it's just extra beads. You don't need the extra beads, the top beads. Oh, I did it wrong. No, no, no. It goes like that. There it goes. There it goes. I did it wrong. There we go. Is that right? No, no. It goes like that. There we go. There we go. All right. Okay. So this is supposed to be 24. Then we go down here, and this is supposed to be 67. So 67 is actually 1 bead on top, 1 bead on the bottom, and then 7. 1, 5, 6, 7. So the idea here was to color it in. So this is what I called a reverse maze, and there's instructions in the front. So the idea was that you start from here and you go forward, but then you see the number and you go back and then you color it in. So that's what I was trying to show you here. All right. So this is about this is only learning how to read the abacus. We're okay how to read the abacus because we've gone through the maze. We've done through part of the maze. So what's the next thing? The next thing is to understand when we move the beads. When we move the beads, again, I mentioned what we do in abacus world is we focus in on the add-in. What is an add-in? The add-in is about the journey, right? We want to know the journey. We don't want to know the destination. I'm a college. I never learned this. I wish they taught this in elementary school. Yes, I'm trying to change that. I'm in the process of trying to change that. So that's when I'm going to flood the school. I'm going to flood the market with all of my abacus worksheets. So again, in school, we're always teaching the kids to how do you make a 5? How do you make a 6? How do but we don't need to do that in abacus world. Why? In abacus world, we need to understand the add-in. The add-in is the thing that we add. How do we move it? So we have the 5 and then we add the 1. We're going to move the 1 bead. Notice it's going to be the 1 bead, right? This is what we're doing. We're adding the 1. Can we do it? Yes, we can, right? So if we have here we have 7. If we have 7, I'm going to add the 1. I'm only going to add the 1. Can we do it? Yes, we can. So what we're going to do is we're just going to add the 1. Does that make sense? It's super simple, right? Super easy. But the reason why we want to do this is to understand how to move the beads. So we have 2. I'm sorry. Yes, we have 2. This one is 5. We add the 5, and what are we going to do? We're going to add the 2. Yes, we can. Yes, we can. Like Bob the Builder. Yes, we can. Can I? Is it here? Is it here? Did you do it? No, it's still going to get approved. Okay. So our final number is 7, right? Yeah. Okay. So we have 6. We have 6. And then we have 2. Can we do it? Yes, we can. We can have to add the 2. When you notice, I have enough beads to add the 2. So that's what I'm trying to do is I'm trying to show you how to move the beads. And then this beginning part is just to know how to move the beads. And again, we're focusing on the add-in. We're not focusing on the result. We don't want to say, oh, this is how you make an 8, this is how you make an 8, this is how you make an 8. No, what we're going to do is this is how you add a 3, this is how you add a 3, this is how you add a 3, right? So here is my question. We have 5 and then we have 3. We're going to add the 3. Can we do it? Yes, we can. Thank you for teaching me this. I got to go. Okay, see you later, Asian kid. I hope to see you in my next lives. Yes, because we got to do adding, subtracting, multiplication, division. Hopefully we can get there. Yes, you can do all 4. And we can also do decimals, which I kind of showed a little bit. Okay, so again, What are we doing? We're doing 4. Notice when I add the 4, we're moving to the horizontal bar. When we are subtracting, what? We're subtracting? Yes. When we are subtracting, we have to move it away from the horizontal bar. Does that make sense? So now we have a balance. We want to add, we go to the horizontal bar. When we subtract, we want to go take away from the horizontal bar. So that's what we're doing in the next one. So when we do is the -1. I have my question. I have 2. Can I do it? Yes, I could take away the 1. I'm going to take away the 1. I need to move it away from the horizontal bar. Does that make sense? So it's a balance. You know how to add, you know how to subtract. It's different than understanding and it's different than memorizing your doubles, right? Memorizing doubles, you know, only can add, but you cannot subtract. You can't subtract doubles because it would just be 0, which is interesting. I didn't know that until I was trying to figure out how to explain it. So the first thing, what we're going to do is we're going to do -2. Again, when we look at the -2, we have 3, and then I want to take away the 3. Can we do it? Yes, we can. We could take away 2. Does that make sense? So what we do is I have my horizontal bar. I want to take away the 2. So my final answer is 1. And again, we're going to do 3. So this is the basics to how to move the beads. Again, if I do this, I want to add the 4. And then I'm going to take away the 3. I'm going to remove the 3. And I'm going to take it away, subtracting the 3. Can we do it? Yes, we can. But then again, notice again, I don't know if I said this before, but be careful of flicking too hard. Like Zeus in Thor, if you flick too hard, then your answer will get messed up. So you have to flick gently. This is a gentle process, right? It's not aggressive. You can't be aggressive. You can't be mad. You can't be mad doing abacus. I'm telling you. So we have 9 and we're going to take away the 4. When we take away the 4, can we do it? Yep, we can do it. So we're going to take away the 4. All we got to do is bring down the 4 beads. And what's after that? After that is adding the 5. When we add the 5, it's the same thing. When we add the 5, we have 3. We're going to do 3. We add the 3, and then what is it? Adding the 5, it goes to the horizontal bar. So then we add 5, and my final answer is 8. Anybody have any questions? Thank you, Sincere, for sharing the live. And then we have 6. Again, when we have 6, we're going to add 6. We're not going to do 1 and 6. What we're going to do, 5 and 1. What we're going to do is we're going to move the 2 beads together because we're big people. And little people can do it too, right? What we want to do, so when we have 8, 5, 6, 7, 8, and we want to -6, I'm going to remove it like this. So my final answer is 2. Does that make sense? So again, we do 7. 7, you start to get into the numbers where don't have a lot of numbers, or don't have a lot of questions. So we have 7, we have 1, and then we add 7. We're going to bring it together like this. And when we minus the 7, we take it apart like this. How are we doing? Are we all right? So I'm lost. What we're doing is we are fancy beadwork now, Miss Lynette. Yes. Can you do double digits subtraction problem for me? Yes. So we have 4, 3 minus 1, 2. Cody. So CompuBear. When we are, how are we lost? So if I have 8 and I want to minus the 6, I take away the 6, 5, 6. So my final answer is 2. Yes, Alex, the blue bead is the blue bead is equal to 5. Yes, thank you. When we added over 5. So this is 5, 6, 7. 5 plus 2 is 7. When I want to minus 6, I do 5, 6, and I move it away like that. Does that make sense? So when I'm adding 6, I bring it together. When I take away 6, I do that. Make sense? So what we're doing is we're adding and subtracting. So what I'm doing is I'm trying to show when we add the 7. So if I have 2 and I'm adding the 7, it goes like this. Do you see how that works? So when I add the 7, my final answer is 9. When I subtract the 7, I do that. What are you left with after you sub 6? I don't know what that means. 73. So we have 73, Cody says, take away 23 as fast as possible. I don't, that's 50. What if we added 8? Well, let's see. If I have 1 and I want to add 8, I add 5, 6, 7, 8, and I bring it together like this. I'm adding 8. When I subtract 8, I want to take away the 8. That's what I want to do. If I have 9, take away 8, I do this. You just replaced my Xbox detective. 2 plus 8. 2 plus, that's a formula that we have to go through. So for right now, we're not working with formulas. Why? Because we need to understand how to move the beads. Are you okay with that, Comfy Bear? The first thing we need to do is understand how to just move the beads. So this is what we call simple, right? The reason why we call it simple is because can we do it? Yes, we can. The next thing to do is what happens when there's not enough beads, right? Are we ready to know what it's like to not have enough beads? Are we ready to understand how to? Okay, good. So what's going to happen is, okay, we're done with this. And again, if I want to add 9 and I want to subtract the 9, thank you, Null. That sounds so intense. It's not that intense. It's not that intense. You know why? Because we get to the point where I'm not sure how old everybody is, and it's okay. But see, I never learned this when I was a kid. I never learned abacus when I was a kid. So I never learned this when I was a child. I learned it when my kids were young. Thank you, Neon Panther. 3 plus. Yeah, I'm old. I'm old too. I learned this when I was old. So what remember is what 4 plus 1 is equal to 5. This is what we're teaching the children. This is what we do is we're learning how to make a 5. Does that make sense? When we make a 5, we want to know how to 4 plus 1 is equal to 5. This is a crucial, this is a fundamental concept. So why? Because we don't, in abacus world, we do not memorize doubles. In school, we're teaching the kids how to use the number line. We're teaching kids how to, I don't know, what do we do? What, I don't know how we're teaching. We're teaching the kids number bonds. So we teach them that 5 and 4, this is 1. We're teaching that the relationship. Mr. Clean, you may feel old, but your spirit is super young and joyful. Oh, you, Mr. Clean. Ah, I appreciate that. Thank you so much. And I laugh. I think it's because I laugh at everything. All right. So we're teaching the children the number bond, right? And then we're trying to figure out like all this stuff, which is fine, which is fine. But then the thing is we don't take it the next step. What does that mean? Well, in abacus world, we actually take it to the next step. We are going to no longer have freeloading numbers. No more freeloading numbers. Can we say no more freeloading numbers? So what's going to happen is when we don't have enough. So what? Oh, yeah, we'll do this one. I have 4. Let's do 4 plus 4. We don't memorize doubles. What we do is we understand that we don't have enough beads. We don't have enough beads. What do we do? No more freeloading numbers. Yes. Thank you, Neon Panther. No more freeloading numbers. So I'm going to add the 4. Notice I don't have a very intriguing. Oh, good. I don't have enough beads. So it's kind of nice. What? So when you are really good at abacus, do people just visualize it in your head? Yes. Yes, people start to visualize in their mind. I can do some numbers, but I don't practice it. But it's a practice, just like a piano, right, Cody? Okay, so understand that there's a constraint, right? If you have a blank canvas, right, like this, if you have a blank canvas, then everything is under the sun. It can be anything, right? And that's when we start drawing it out and we start talking about beats. But in abacus world, we have a constraint. We can utilize this to our advantage. I wanted to say no more freeloading numbers, but I'm kind of freeloading right now. Yeah. Okay, so the constraint actually helps us. You know, they talk about how discipline is the best thing, right? The discipline will give you freedom and all this and that. Okay, so it's the same thing with abacus, and it's really interesting. Abacus gives you a constraint, but the constraint will actually make it easier for you to understand. What's going to happen is we're going to utilize this 5. Why are we going to utilize 5? Remember that there's this concept. This concept is what we're going to use. We're gonna use this concept. It's called the abacus formula. We're gonna utilize this 5. When we utilize the 5, we have 4 plus 1 is equal to 5, right? We know this. This is what we're teaching the children. This is what we're teaching the children. Yeah, teaching the children. Now, if you notice, right? You're not a number, so it doesn't count. You will notice that we're going to isolate this variable, right? When we isolate the variable, what are we going to do? Why are we going to isolate it? Because we're looking for this 4. So in algebra, we know this, right? We isolate the variable. X plus 1 is equal to 5. When we go to x plus 1 is equal to 5, we want to isolate this variable. We want to make the variable by itself. We want to make the 4 by itself. To make the 4 by itself, we do 4 is equal to 5. Wait a minute, wait a minute, wait a minute. 4 plus 5, 4 equals to 5 is not balanced. So now we need to do is we need to balance the equation, right? We know to balance the equation, we need to minus the 1. What? What does that mean? So what we're going to do is we're going to add the 5 and we're going to take away the 1. And my final answer is, can you put in the chat what the answer is? Put in the chat what the answer is. 8. Thank you, Null. So what did I just do? What I did was I understood a concept, and this concept can be, thank you. I zoned out, Miss Lynette. Ha, no worries. We're going to do it again. We're going to do it again, right? Thank you, Anna. Yes. So what we did is we understood this concept. We can do it again. Let's do 3. We're going to add 3 to our abacus. When we add 3 to the abacus, what are we going to do? We're going to add 4. Remember, we don't memorize, right? What we do, you could count 5, 6, 7, 8. You could do that. You could start going through and doing number lines, but we don't do that in abacus world. What we do in abacus world is understand this concept. We have this concept 4 plus 1 is equal to 5. We know that 4 plus 1 is equal to 5, but because we have this concept, we can modify. Where is it? Where is it? Where is it? Right? So what we're going to do is we're going to modify it. We have this concept. We're going to substitute this information as the number 4. So what are we going to do is we're going to add the 5 and we're going to take away the 1. So my final answer is 7. Does that make sense? So what do? We're taking this concept of, I love the sound effect. Yes. I've got more. I got more. Yeah. Zeal. So abacus makes math so much easier. Does that make sense? So Anna, did that make sense? What we did is you can do the number lines. That's not a problem. But in abacus world, we don't do number lines. In abacus world, we have concepts. Hello, anime. Anemo. Yes. Okay. Yes. Generally, this would have been saved my math career in school. Yes. So what we're going to do, Anna, I think because you came in, what we're going to do is understand how to read the abacus. So we're going to do a little review. Let's review. Oh, I should do another soundbite that says, let's review. Okay. So let's review. We're going to count on the abacus. We have 1, 2, 3, 4. And then we have 5. The top beat will always be 5. We have 5. We have 6, 7, 8, 9. Because we have 9, now we can do 10. Notice when we do 10, and I have my little label thingy right here. Thank you guys for the likes. I have ones, tens, hundred, thousands, 10,000. So when we look, we have 10, 1 and 0. We have 11, 12, 13, 14. After 14, we can do 15. Does that make sense, Anna? I am going to continue on. So the next thing we're going to do is understand. We could do the same thing. We could do it again. Do it again. Do it again. Okay, so we'll do 2. We add the 2. The question is to add the 4. When we add the 4, is there enough beads? No. So how do we do it? We understand this concept. We know how to modify and we modify it. And so, can you teach me addition? That's what we're doing, right? So what we're going to do is we're going to add the 5 and minus the 1. Notice it gives you directions, right? This is giving you directions on how to use the abacus. It's the most obvious thing that is right here. Does that make sense? It's telling you how to add it. When we look, we've done 4. When we want to add another 4, we don't memorize doubles. What we do is we understand this concept. This is a fundamental concept. Like waxing on and waxing off, like, what do you call it? Like Karate Kid. Are you going to be on later? Yes, I will be on later in the day, Amino. Yes, I will be. I usually go twice, one in the morning and one in the evening. Okay. Does that make sense? So it's like waxing on and waxing off. It's the most simplest thing to do. Wax on, wax off. Okay, yeah. I'll see you in the next live. Thank you for joining. Thank you for coming by. So again, we're waxing on, right? We want to add the 4. We want to wax on. And then what are we going to do? We're going to wax off, right? To minus the 4. Why are we going to minus the 4? We're going to minus the 4 because the question is, what's the question? Let's do 7 minus 4. So when we do 7 minus 4, what are we going to do? We know that we want to isolate this variable. So if 4 minus 5 plus the 1, because we got to move this over here and we can make it more balanced. So if we have 7, notice I cannot take away 4. I cannot take away the 4. So if I can't take away the 4, what can I do? I have this concept. Now we're compounding our concepts. We know how to make a 5. Now we can take away how to make a 5. So we minus the 5 and we add the 1. And my final answer is 3. Right? We're not memorizing and we're not using number lines. We're not using number lines to be like, okay, 7, 6, 5, 4, 3. We're not doing this, right? Because we don't need to do it on the abacus. We don't do 1, 2, 3, 4. We are not doing that. We don't need to do that. What we need to do is we need to understand this concept. So then we start going into critical thinking. Critical thinking, right? I know in mainstream math, they talk about number lines and number bonds and all this stuff. The number bonds kind of make sense, but this solidifies the concept. Does that make sense? Anybody have any questions? How are we doing? How are we doing? That's what we're doing. We're on this one. Yep. Cool. How is it 3? How is it? Oh, so if we did 3, how is it 3? If I had 4, if I had 7, if I have 7, no, 7, if I have 7 and I take away 4, I take away 4, but I can't because I only have these two. How do I take away 4 from here? When I take away 4, I'm going to minus the 5, so I have to take away the 5 and I have to give you back the 1 penny. I'm good. Just mesmerized. I feel like my brain is gaining wrinkles. Yes, my brain hurts a little, but I think I'm getting it. Yeah. Okay, let's take it one step further. Let's take it one step back. So here I have 3. But the problem is I only have a nickel. I want to give you 4 pennies, but I only have a nickel. So what am I going to do? I'm going to give you my nickel and I'm going to exchange it. I'm going to take back 1 penny. So my final answer is 7. Does that make sense? What we're doing here is now we're doing the opposite, right? I only want 4 pennies, but I can't take away 4 pennies, right? Because a nickel is 5 pennies. I'm not sure where everybody is. So this is worth 5 pennies. This is worth 5 cents, 5 whatever. But I only want 4. So what do? I have to take away the 5 and I have to give you in exchange the 1. So then we have 3. That's how it's 3. Does that make sense? Oh my God, there's 42 people here. How are we doing? So what we're doing is we're understanding the, okay, great. I'm getting it now. Okay, good. Yeah, sometimes it's helpful to have money because we work with money a lot, right? And so when we look at it, and obviously I don't know where everybody is, but I'm assuming that people will know what this is. Oh yeah, 51. So this is a nickel. This nickel is worth 5 cents. Because it's worth 5 cents, I can utilize it, right? But I have to figure out how to exchange it. Yeah? How are we doing? So when we do the minus, I have 7, but I only want 4 pennies. So when I take 4 pennies, I'm going to move it away. I'm going to give you my 1 penny. So that's why it's 3. Okay, so we're good on that? Okay. Do we want to do more questions on how to make a 5? Because if not, we can go to the next concept, which is how to make a 10. How are we doing on the concepts? So these are big concepts that we're teaching kids. Yes, please. More fives? I'm sorry. I tens. Okay. Can we do a few more fives? Okay, yes. Let's do a couple more fives and then we'll go into the tens. So here we have, we can do another set. We can do how to make a 3, right? We're going to add the 3. Notice this is the add in. Thank you, Zeal. No, no, thank you. Thank you, Zio, for letting me know. I want to make sure everybody understands, right? So what we're going to do is we're going to notice I'm looking at the add-in. I'm not looking at the result. I'm looking at the add-in. So here is my add-in. If I want to do 3, when I want to add the 3, what do? I have my formula. 3 plus 2 is equal to 5. Let me rewrite it. Oh, that's right. It was a big number. Okay. So what we're going to do is we're going to do 3. Oh, yeah, we'll do a big number. I'll show you how it's scalable. So we have the 3. What we're going to do again, we're going to isolate the variable and we're going to move this to this side. So what does that mean? If I have 3, this is where we get critical thinking. This is where we have to start thinking, what can I do? What can I do? This is not just do whatever. This is, how can I do it? Can we do it? No. How can we do it? There's always a way to do it. So if there's a way to do it, what are we going to do? When we isolate the 3, that's what it looks like. And then what does that mean? This means that it is no longer balanced. Because it's not balanced, I'm going to minus the 2. So I'm going to add the 5. I'm going to take away the 2. So my final answer is 6. Now, how is this interesting? How is this possible? It's because we're understanding how to utilize our 5. But the greatest thing is when, I don't know if I wrote it. I should have wrote it down. The greatest thing is when the numbers get big, right? So when the numbers get big like this, 100, 100, 1000, 1, 2, 3, 4, 5, 1, 3, 5, 7, 8, right? And then what are we going to do? We're going to add 2, 4, 3, 1, 1. We add 2, we add 4. Can we add the 4? No, we can't add the 4. How do we add the 4? Do we remember? Is there enough beats to add the 4? No, there isn't. What do we do? Put it in the chat. What do we do to add the 4? Plus the 5 minus the 1. Yes, thank you. Yes, Bagel Racer. Yes. We're going to plus the 5. Oh, I see you later. I have to go tutor. Okay, I'll see you later, Mr. Clean. Yes, thank you, Compy Bear. So plus the 5 minus the 1. Yes. So now it's scalable. No, we got to move the blue bead. Yes, thank you. Hey, Bray Bray. So then we add the 3. Is there enough to add the 3? Yes, I'm going to add the 3. Is there enough to add the 1? Yes. And is there another one to add 1? Yes. So notice now it's scalable. Even though the number is big, it all depends on that single place value, right? This concept is placement agnostic. Does that make sense? Now we understand that it's very versatile. It just matters on what the number is. Yeah. Yeah, right? 300, 37,889. I'm very happy. Thank you so much for asking. I love that term. Yeah. Position agnostic. So, my friends, I'm placement agnostic. Right? Because why? This is it's a very simple concept. But it can be utilized. It doesn't matter what column it is. In the abacus, well, you have a good day. You too, Bri. Thank you so much for dropping by. You have a good day too, and I will see you in my next live, or I'll see you in Audrey's live. So does that make sense on how versatile this fundamental concept is, right? It's easy to be like, oh, you're making it complicated because of this. But when you get it into a bigger number like this, you don't need to see, okay, we're going to take away the one from here. Or we don't need to do all the other strategies that are out there. I don't know how to do the new math strategies when it comes to big numbers like this. I just know how to add it on the abacus, right? And so what we just did is we just added on the abacus. We understood how to add a five. That's all we did. But then everything else was, is there enough beads to add each column? Yes, there is. So we didn't have to worry about it. Does that make sense? How are we doing? We all right? We can do some more. So here we have four. We're going to add four on the abacus, right? When we add four on the abacus, I'm going to add the three. I don't have enough beads to add the three. Because I don't have enough beads to add the three, what do? I have directions. I have a mapacus. I have a map that's an abacus. I have a map abacus. Anyways, so I'm going to add the five. I don't need to worry about it. I don't need to memorize. I just need to, well, this is, you have to memorize, but I don't need to know what this means. I just need to do it. Plus the five minus the two. So my final answer is seven. Mapacus. Map abacus. I think I'm going to try to get that termed. Map abacus. Because what is this? This is directions on how to use the abacus. That's what it is, right? It's just directions. Maybe it's a directicus. Direct. I don't know. I'm trying to figure that one out. Map Mapicus. Yeah, I don't know. I'm still trying to figure that one out. So when we look, right, some people are like, you're making it too complicated. It's like, well, then why are we teaching the kids how to make a five? I don't know why. What's the point of learning how to make a five if you never really use it? So in the abacus world, we actually utilize it. Okay, are we ready for a plus 10? I love this actually. Oh yeah, right? Yeah. I mean that's why I teach it. So I've been teaching abacus for about 20 plus years, but getting it into mainstream math is what my goal is. Yes, I'm ready. Okay, good. Yes. Okay, good. So now what is the next step? The next step is what? How do we make a 10? Just like in regular math, right? Regular math, what are we doing? We're how to make a 10. Why do we need to know how to make a 10? We're needing to know how to make a 10 because we're doing carrying on. We tell the kids to carry on. It's the same thing. But it's interesting because in abacus, these are always going to be the pairs and no matter what. These will always be the pairs. Which I don't understand is in mainstream math, they give you pairs like 5 plus 7 is a pair. And I'm like, what? 5 plus 7 is not a pair. How is that a pair of anything? That's not a pair of anything. I don't get it. So I don't understand why we have more pairs. I think what we do is in abacus world we just focus on these fundamental pairs. That's it. Just like we have the fundamental pairs for the plus 10, the adding of the five, right? Because we have that. These are this is what? This is the fundamental. It's a fundamental. And I will tell you the secret at the end. There is a secret I have. So here we are at how to make a 10, right? How do we make a 10? What are we going to do? We're going to add an 8. Why are we going to add an 8? What question do we have to add an 8? Well, you will see. So we have 7. We have 7, and I want to add the 8. I have 7. 7. I want to add the 8. Is there enough beats to add the 8? No, there isn't. So what do? We know we're going to what? We're going to isolate the 8. We're going to isolate this number. So what is it? It's 8 is equal to 10 minus 2 because we got to move this over to the other side. So we isolate this. We're going to substitute. What? See, it's a pattern. We know how to do it with the 5s. Now we can do it with the 10s. It's no different, right? It's exactly the same except the numbers are different. Again, we're looking at the add-in. We're not looking at the result. We're looking at the add-in. So here is, your gasp sounds so authentic. I've been doing this for a little bit. What are we going to do? When we added 10, 0, 1, 0, 1, adding a 10, we know how to make a 10. We have 1, we have 10. Notice there's a 0 here. So when I have 7, I'm going to add the 10. 10 is too much. I need to take out. Do I have a YouTube channel? Yes. It's in my link in my bio. I minus the 2. I'm right there now, actually. I stream everywhere. So what do we do? So what we did is we minus the 2. Yeah, go to my link in my bio and you'll see all my lives there. Yep, 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 yep. So that's the answer. Does that make sense? What did we just do? Well, we'll do an exchange, right? We do an exchange. We have 7. We have 7, right? But I only have a nickel. I only have a dime. I only have 10 cents. Because I only have 10 cents, I'm going to give you 10 cents, but it's only worth 8 cents. I'm going to give you my 10 cents, but I got to take out 2 cents in exchange. So my final answer is 15. Does that make sense? Yeah. So what did we do? What we did is what we did is we used money. One, we used money, but two, we're making a 10. So this concept of making a 10 is very similar to carrying on, trading, borrowing, grouping, regrouping. But in abacus world, we don't talk about it like that. Well, in abacus world, what we say is plus the 10. Plussing the 10 just means add the 1 here, and this is a 0. Add the 1, 0. And then what do? I take away the 2. I'm going to minus the 2. So my final answer is, thank you, Bear. You too. Have a good day. Have an amazing day, you too. I hope to see you in my next live. It was good conversation. So then when I take away the 2, what do I have? I have 15 that's left. I'm going to find an online abacus and practice now. And then I'll teach my kids. Yeah, that's fantastic. You know what? There's a bunch of abacus apps if you have a on the App Store. Okay, Bear, I'll see you later. Thank you. No, thank you. See, my third eye is opening. Yeah. Oh, good idea. Yeah. Yeah, I'm not quite there yet to make my own app, but I know there's a bunch of apps out there. And if you're looking for abacus worksheets and workbooks, I do have those available either in my TikTok shop, or if you want I'm still building out my shop, but if you're looking for more activities, these are the places where you can find my activities. Either my website, where it's a digital download, you can buy the actual book, or you can go to Teachers by Teachers and have worksheets. So I'm trying to consolidate everything and try to make it all the same, but I've just been producing a lot of worksheets, but they're all abacus specific. Are you thinking of building your own app at one point? I am planning to it, but for right now, my goal is to get enough content and worksheets available so it's available for everybody. But yes, that is the plan, but not right now. I don't have the bandwidth to do that right now, because I'm just doing this right now with all the lives and just educating everybody on what an abacus is. It's taking a lot of time, even like brain power, to like figure out. Because my worksheets, my workbooks are not just here's a bunch of numbers. There's like activities that go with it, and so it takes some time to build out my workbooks. So right now I'm on my 10th workbook, and what I'm doing, and so this one is a puzzle. You answer the puzzle. This is the puzzle board. You answer the puzzle and then you find the answer here. So, but it does take some time, and the way I would want to do it, it'd be very specific. I haven't really thought about that. So this one here is solve the hidden word, and you answer the question and then you find the answer, and then there it goes. I'm just glad you're a human making human workbooks. Yeah, take your time. I say, yeah, thank you. I appreciate it. I appreciate it. There's no there it, everybody's like, just use AI. It's like, no, AI cannot do abacus specific questions. So when we look, oh, you know what? Even better. So I have a parent who is trying to figure out not customize, how to abacify the curriculum that she has. And so she was kind enough to give me some examples of what they're doing. Now this is very specific, but if you notice, they're kind of all over the place. Why? Because in abacus world, we have a specific framework. We have a 5 and we have a 10. The questions are very specific. So let's take the first one. I don't know if I can do that. Maybe I'll do it this way. The questions are very specific. In the abacus world, because why? It's structured. So here, this blue or this green, this is what we call simple. That means that, do I have enough? Yes, we can. So if I have 5, right, I'm going to add 5. I want to add the 4. Do I have enough? Yes, I have enough. I'm going to add the 4. But then let's take it this one. We have 4 plus 4. Well, notice I'm going to add the 4. I don't have enough to add the 4. What do? I need to use my formula. Plus the 5 minus the 1. So then what happens? Okay, well, let's do another one. Let's do 8. I want to add 4. When I add 4, I'm going to add 8. Do I have enough? No, I don't have enough. What can I do? What do I do is that now I have to do the plus 10s. Plus 10s is what? If I want to add the 4, how do I do it? I have to, my pair of the 4 to make a 10 is 6. So what do? If I'm going to isolate my 4, I'm going to do 4 is equal to 10. That's not balanced. I'm going to minus the 6. So when I have 8, I'm going to plus the 10. I'm going to take away the 6. So my final answer is 12. When we do it, that's what the yellow is. The yellow is making the 10s. The pink is making the 5. How are we doing? Does that make sense? Thank you guys for liking the live. Does that make sense? So what are we doing? We're compounding our knowledge. We're compounding our but it's a framework, right? It's a very specific framework. So it's the same thing with the subtraction. So this is the addition table, and then this is the subtraction table. And it's the same thing. We have our, can we do it? Yes, we can. Can we do it here? No, we can't. This is where we have to do the minus the 5s. And then this is, so let's do 8 plus 8. Thank you. So let's do 8 plus 8. Well, let's take a look. 8 plus 8 looks like it's a 10. How do we do it? Well, let's do it. Let's do it. Again, we do not memorize doubles. What we do is understand our concept. Where is 8? 8 plus 8. Oh, here it is. 8 plus 8. Ah, here it is. 8 plus 8. So I'm going to add the 8. I'm going to add the 8. I'm going to add the 8. I got the 8. Okay. So CompuBear says 8 plus 8. We're going to add another 8. We don't have enough beads to add the 8. So this is where I had the little story. The story is, do I need to use the asteroid belt? That asteroid belt is the 10s. So what we're going to do is we're going to plus the 10, right? We're going to add the 10, but we only need 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. We add it to the 10. But then we have 2 left over, so we have to take out 2. So we minus the 2. So our final answer is 16. And that's what we did. So our what? Our formula that we're using, we call it formula, right, is 8 is equal to plus the 10 minus the 2. Yeah. So again, we don't memorize 8. We don't memorize 8 plus 8. We don't memorize doubles because now we can go versatile. 7. Let's do 7. I have 7 on my abacus. Can I add the 8? No. No, I can't add the 8. What do? I go to the asteroid belt. I add 10. And then what do? I minus 2 and I take away the 2. So my final answer is 15. We can do it again with the 4. We do it again with the 4. Let's do the 4. I want to add 8. Is there enough to add the 8? No. What do? I go to the asteroid belt. I add 8, which means I go to the 10. And what do? I take away 2. So my final answer is 12. I could do it again. See how it's very, the repetition is practice. But see now, cuz we know how to add an 8, it doesn't matter what the number is. Excuse me. I have 9. I want to add the 8. I don't have enough beats to add the 8. Yeah, right? Easy. Plus the 10 minus the 2. My final answer is 7. And now, and now what? Because we know how to read the abacus, now we know how to move the beads. And this is the reason. Oh, to ensure a safe shopping experience, use a TikTok live product showcase to sell instead of directing customers into. I'm not. I'm right here. Yes, I'm right here. Make sense? So for those of you that just kind of come in to a conversation, it might seem more complicated, but knowing the foundation, right? Understanding why we're doing it, then it becomes more versatile. Super. Oh, cuando son I'm sorry. ¿Cuántos son los lives? How? I don't know. I'm sorry. I don't know Spanish. How many lives? I'm not sure. Oh, when are your lives? Ah, thank you. When are my lives? Sometimes in the morning, sometimes at night. Follow me and you'll get notified. Yeah, there. I've been trying to do. Actually, I've been trying to do morning and night. But the problem is I'm in California, so when I come on at night, it's like midnight for East Coast, if that makes sense, and it gets a little late. So I'll Alassane, if you have any questions, let me know. I see you. So yeah, I'm pretty random right now because kids are still young. Oh, thank you so much for liking the live. Oh yeah, okay, so yeah, does that make sense? So I tried to do here is I try to add in a story for the kids to understand, because my thought was when I started this journey was I was going to only be talking to young kids. But going down this journey, there's a lot of adults, there's a lot of older people that are interested. And so I'm actually in the process of creating a workbook for adults. So it'd be like introduction to abacus for adults. And I was thinking, and some people were like, well, why are you doing that? I go, well, it's just like using Sudoku, right? So Sudoku is like brain gymnastics. It's like Sudoku, was it crossword puzzles and word searches. Those are all very much like brain gymnastics. And so I think we don't do enough. So that's why I'm going to add in learning the abacus would be another thing to do brain gymnastics. So that was my plan. That's my thought. That's my that's my thing. But yeah, I've been teaching abacus for 20 plus years, and so I'm just now expanding it into the internet, and I am very happy that you guys appreciate it. I'm very happy that you guys are available. Thank you guys for helping me translate. Yeah, I don't. Yeah, it kind of. I haven't. I don't remember my Spanish, obviously. Yes, yes, we do. Thank you very much. Oh yeah, under skills. Yes, thank you. So what we did. Okay, we understand how to make a 5. We understand how to make a 10. That's it. That's the secret. The secret is once you know how to make a 10 and make a 5, you will know how to do everything. Now the question is how does it all fit? Your lives with the tomorrow. Yes, in the mornings and nights. Yes. I try to go twice sometimes, but I try to go at least once, if that makes sense. Oh, thank you, Zeal. Thank you so much. So, what does that mean? Okay. So here you'll notice I have these things, right? And these things what they do is they have these little things. Plus the 5 is equal to plus the 10 minus the 5. I try to use what I know at least. Yeah. Yeah, or there's Google Translate. But thank you, I appreciate that. So we have, but okay, this is we have. This is everything about the plus tens. This is everything about the fives. It makes me some time to remember certain words, and I often double check before sending things. Oh yeah, thank you, thank you, thank you. Um, so if you notice, we have this minus the or plus the four. We'll do plus four. Plus the four is what? Plus the five minus one. But wait a minute, this one also has a plus four minus the five. What? But they're different. How are they different? They're different because it depends on when we're using it. So if you notice, we had eight, and when we want to add the four. When we add the four, the question is can we add the five? No, we cannot add the five. So what's the next thing we have to do? Because why? We're already using the five, right? Adding the five is plus the five minus the one, but we cannot plus the five anymore. So what do? We have to go to the next one, which is the plus 10. Plus 10 is what? Add the four is plus the 10 minus the six. So I add the 10 and I take away the six. So then my answer is 12. And that's it. That's everything that you know. Now what's going to happen is, let's do the next question. What's going to happen when we call it in my world, it's no longer abacus world. In my world, we call it two-step equations. Why is it a two-step equation? It's a two-step equation because I'm trying to make it more popular. I'm trying to popularize abacus. So two-step equation is a very much a algebraic term. So one parent I had was 8 plus 5 is the same as 5 plus 8. It is not. It is not. I gotta go. Okay, thank you, Zeal. I'll be back. Thank you again for educating us. Yeah, not a problem, Zeal. Thank you for joining. Is there a way we can write it out? I have to see visually. Is there a way to what are we talking about? How to read this? Let's see. Like this? Like that? So we have one, we have two, we have three, and then we have four, right? After four, we have five. The five is always going to be the top beat no matter what. The five will always be the top beat no matter what. Because now we have six. Six is this. Five, six. Seven, five, six, seven. Five plus two is seven. We have eight. Five plus three is eight. No, 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 not 6, 7. This is not 6, 7. Then we have 9. We have 9. 6, 7 looks like this. 6, 7. Does that make sense? 6, 7. The top bead will always be 5. The bottom beads are always 1. When we look, 1, 2, 3, 4. Right? 4. The top bead will always be, the bottom bead will always be 4. 5. So we have 5, 6, 7, 8, 8. 5 plus 3 is 8. 5, 6, 7, 8. 5, 6, 7, 8. And then we have 9. That's 9. Ignore 6, 7. It's a thing. Yeah, I know. I think it's the funniest thing. Doc, it's just a single number you're showing. Yes, exactly. It's only the single number. If I do double digits, 1, 0, 11, 12. Hey, Bible, good morning. Yes, good evening, Bible. Good evening. We're doing a review on abacus. Welcome back. Hey, Panda. We're doing a review on abacus. 13? 13. I didn't write it out. 14 and then 15. 16, 17, 18, 19. We can count by 20s. We can count by 10s. 10, 20, 30, 40, 50, 60, 70, 80, 90. Why? Because every column is a place value. Doesn't matter where we put the numbers. It only matters where your dot, this is your ones indicator. This ones indicator tells me where the ones is. You can use this one like a Pokemon. I choose you. But if I choose this one as my ones, then I have to shift everything over. So it'd be my ones. But notice I have my ones and my tens. I don't have any more hundreds. So that's why I choose this one. I can have ones, tens, hundreds, thousands, 10,000. After thousands, right, there's a decimal. The decimal sits between the ones and the tenths. So now I have a decimal. Tenths and then the hundredths. Welcome back. Does that make sense? Rodriguez? Hello, Aubrey. Thank you so much. Or money. Yes, or money. Well, yeah, or money. But if we do here, that's a lot of decimals right there. Yeah. Yeah. Not a problem. Thank you for asking. Yeah, that's a very good question because nobody really sees this. So when we look, oh yeah, so let's do $2. $2. I'm sorry, $2.66. That's what that looks like. Yeah, 66. Yep, $2.66. This one is a 7-column one, and this one is a 13-column one. This is the clearest someone has explained it. I get it now. This is awesome. Oh, that's funny. Ah, that's fantastic. It's really interesting. I'm actually trying to use some algebraic terminology when I talk about the abacus. There's not a lot of algebra in abacus. I'm just letting you know. But I'm trying to figure out some math terminologies to relate to abacus, which is, great. I bought your abacus. You did. Put it in my pocket, take it to the grocery store. That's fantastic, kid. That's fantastic. So this one was the reason why I brought this one out was the same thing. Here you have your different dots. These dots are your indicators. At the end of the year, it'd be a fun lesson with my kiddos. It would be, yeah, it would be interesting. I do see a lot of people that's interested in the abacus, so it'd be fun. Yeah, and then when we read it, right, we have to make sure we understand that all the way we have it, all the lower beads. If you have one, do you have an abacus, Nikki, in your school? If you do, is it how many beads does it have? Because you can modify it. Um, Now you have a calculator. Bible, the brain is a calculator. If you really think about it, the brain is a calculator. This only stops us from writing it out on paper, which is interesting. Like the concept of saving paper. It's just yeah. I mean, I don't. I mean, I'm using all the papers my kids are not using. Oh, we're back to here. Sorry. So, what does this mean? So let's go back. We have 8. Now, does it change when you have more columns? No, it only changes if the numbers are bigger. So when we look, we can do ones, thousands, millions, billions, and trillions. This one can only does ones and thousands. If you want to track the national debt, I would use a bigger abacus. I'd probably use a 23 column abacus. And then we would do ones, thousands, millions, billions, trillions, quadrillions, and then quintillions, whatever. I don't know what after trillions. But yeah, the only difference is between the abacus is the amount of digits you want in your question or whatever you're tracking. Does that make sense? When we do that, yeah. That's the reason why it's interchangeable. What I do, I don't sell this one. This one is my own personal one because I've been teaching for 20 plus years. This one's made out of bamboo. This is made out of plastic. So, yeah, not a problem. So this is made out of plastic, and the question is some of the questions would be like, well, these are really small for my fingers. Like, no, 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 no. You might have big burly hands, but you're only using the edge of the beads, right? You're only not delicate, gentle. You're being gentle with the beads, right? So when we do it, we're only going to be grazing the top, right? Grazing the edges of the beads. You're not going to be aggressive, and you're not going to like flick them all over the place. Because if you flick it, you'll notice that your answers will come wrong, right? It's a very gentle tool. So you can't be angry. You can't be angry doing math. You have to be gentle, and you got to just kind of like move it, right? Okay. And also notice that it's very easy to mess up your answer. So you have to stabilize it with your hand. Stabilize it with your left hand, and you calculate with your right hand. Yeah. Let me know if you have any more questions. These are fantastic questions. But yeah, that was one of the things. It's like this is a standard size. The way the height is of the abacus, it's the standard size. It is everywhere. You cannot get anything bigger. You could get something smaller, but you can't get anything bigger than this. This is a standard size abacus. Even this is a standard size. If you notice, they're kind of like roughly the same size. But these beads are smaller. These beads are even smaller, and it's 20 years old. I don't know if you can see that. But you'll notice the difference. The beads are smaller compared to this one. So, but yeah, no, these are great questions. Anybody have any more questions? And so when we look, right, again, you want to be gentle. We want to be happy when we do math. We don't want to be aggressive and be angry. All right. So here was a question that a parent had asked. And it's like, well, isn't this the same? Oh, is there an advantage with the Chinese abacus and the Japanese abacus? Uh, I would say Bagel Racer that the Japanese abacus is more efficient. There's not too many Chinese abacuses out there anymore. The norm now is this one. Math makes me angry. Math is relaxing. Adding and subtracting is relaxing. So, J. Lee, what is it for? Yeah, yeah, you're welcome, Bagel Racer. This is for counting. That's it. It's just for counting. It's just for doing math. We're doing arithmetic. We're doing adding, subtracting, multiplication, division. So the first thing we're going to do is understand this quick maths. Yes, it can be quick maths, but the biggest thing is to understand how to use it. When you understand how to use it, then you can become quicker. Um, but yeah, so what we're going to do is let's do a review. We're going to count on the abacus. We have 1, 2, 3, 4. All the beads touching this horizontal bar and adding money. Yes, it started off with adding. It started off with counting money, right? Like right after bartering, they had the money system, like back in the Mesopotamia, like back in the day when they started doing money systems. Then they started needing to count and track all their stuff. So abacus, the word abacus means moving pebbles, I believe. So we have 4. After 4, we have 5. The top bead will always be 5. And after 5, we have 6, 7, 8, 9. And that's it. That's it. That's all we're done. But then, well, how do we do 10? 10 looks very similar to this 1, but just to be in a different column. So now we're in a different column. This is the ones, this is the tens. When we look, we have our ones, we have our tens. So after 10 comes 11. That's correct. We have 11. And then we have 12 and 13 and then 14 and then 15 and then 16, 17, 18, 19. So what we're doing is we're learning how to read the abacus. When we understand how to read the abacus, we can actually do some adding and subtracting. 33 would be this 33. You're right. And then after 33 is 34. After 34 is 35. But understanding how to read it on the abacus is what we're trying to, what's the goal, right? So I don't know if Jay Lee is still here. Willie Nelson, I think, has gotten it, right? So if I wanted to do this year, right, 2025, that's the year, right? 2025. And then what are we going to do, right? So I don't know what your birthday is. I assume that if you're the real Willie Nelson, I think he's dead. And I don't think anybody knows who Willie Nelson is. I'm sorry. Okay, so what we're going to do is, does that make sense? Oh, so the question is this. So the question is this. My parent was like, "Well, isn't this the same?" Well, yeah, it's no, it's not the same. The reason why it's not the same is because what we want to do is we want to focus in on the add-in. The add-in again is what? The thing that we're adding. We don't focus on the result. We focus on the add-in. Now, how is it different? Well, when we look, we have 8. We have the 8, and then what are we going to do? We know how to. Hank Hill's favorite artist was Willie Nelson, King of the Hill. I'm not sure if anybody else knew who knows who Hank Hill is. So we have 8. We're going to add the 5. When we add the 5, right, we remember how to add the 5. We're making a 10. When we make a 10, what is it? 5 plus 5 is equal to 10. Well, we have this concept. After we have this concept, I'll tell you what. I'm telling you. Boy ain't right. You know, yeah, yeah, please. Okay. Anyways, we have 5 and then we're going to have a 10. We're going to make a 10. So what to make a 10, we're going to add the 10, right? This is where we do the carrying over. When we carrying in the over and we minus the 5. So when we minus the 5, what are we going to do? We do the carry over. We carry over, we add the 10, and then we take away the 5. So my final answer is 13. I cannot remember any Willie Nelson songs off the top of my head. Yeah. I know Kenny Rogers. Monty. Do another one, please. Oh yeah. Well, I'm continuing on with this concept. So what it is here the problem is 8 is different. It's actually 13. You're right. It is 13. But this is different. Why? Because when we use the abacus method, we have 5, but we don't want to know what the destination is. We're not doing destination. We got to divorce the result. We have to marry the process. We have to understand the journey. We need to. I struggle with, oh yeah, more than 2 numbers. So what we're going to do is we're going to understand it's the 2-step, right? And what we're doing is we're understanding what that means. So in abacus world, we're going to add the 8. We know how to add the 8. When we add the 8, it's adding 8 is plus the 10 minus the 2. No, I only think about Kenny Rogers. I only know Kenny Rogers songs. I don't know Willie Nelson. Now I have to go listen to some Willie Nelson now. All right. So we're going back to here. We're going to add the 10. When we add the 10, we have to take away the 2. If we take away the 2, cat, what do? We cannot take away the 2. So notice I'm trying to take away the 2 here. What do we do to take away the 2? See, I listen to Johnny Cash. I know Johnny Cash songs. I don't know Willie Nelson. Bring up the 5. Yes, exactly. So what we're going to do is to minus the 2, what do? Minus the 2 in abacus world, we do minus the 5 plus the 3. So what we're going to do is we're going to minus the 5 and then we're going to add the 3. So my final answer is 13. So what this means is it's a two-step equation because we can't do it anymore. We got to do another substitution. We have to do another concept. So knowing this is understanding the two-step equation. Does that make sense, Kat? Yeah. Yeah. So we take it one number at a time, one step at a time. I know in mainstream math, we do multiple steps all at once. But in abacus, what we want to do is we want to utilize we want to have manageable chunks. Monty, does that make sense? We can add another one, right? So let's do the other number, right? I'm really upset I don't know Willie Nelson songs. Yeah, I remember Johnny Cash. Obviously, there's Elvis Presley. Kenny Rogers was the one that I grew up with, and I'm old. All right, so let's do this one. Oh yeah, okay, let's do 18 plus 15, which is the same, right? So what are we doing? We're doing 18 plus 15. Now when we do it, we have now this is where it becomes a little versatile, right? We don't do ones and then do tens. We take it as a whole. We do 18. So 18 on my abacus, 18. I have 18, right? And then I'm going to add 15. I add 1, and now I have to add the 5. Well, what do we do? When we add the 5, we know what to do, how to add the 5. Can we add a 5? No, we can't. So we know this concept. This is a concept we're teaching the children. We're teaching the children how to 5 plus 5 is equal to 10. But in abacus world, we modify this concept. Adding the 5 is equal to plus the 10. This is where we carry over, and then we take away the 5 because adding the 10 is too much. Adding the 10 is too much. So we need to minus the 5. So my final answer is 33. Did that make sense? Glebo? Glebow. Yeah. It's a very good question. It's a very good question. But see what we did here, if we did it in if we did it in mainstream math, what do? We do this is I don't know, 13, right? 3, and then we carry the 1. And then we do 1, 2, 3, so then we have 3. But in abacus world, we don't do that. In abacus world, we take the number as it is. So we do 18, we do 1, I add the 1, and then here is I'm adding the 5. Because I'm adding the 5, how do I do it? Now it becomes scalable, right? Because what happens is when I get more numbers, let me see. When I use more numbers, obviously it's easy when there's only two add-ins, right? It's fine when it's two add-ins. So they have their own formulas. Yes, Monty. Yes, exactly. So on paper, we add from right to left. On the abacus, we add from right. Yes, exactly. And so let's say we get a bigger question. So here's my question, right? If I have 67, 5 minus 6, right? This is a very common thing. In abacus world, we do more than just two add-ins. In abacus world, we do multiple add-ins. So that's why we can never know what our answer is. We can never just see this and say, oh, that's the number, whatever. So when we do it, we have 67. Then what do? We add the 5. When we add the 5, what do? Plus the 5 is equal to plus the 10 minus the 5. So I'm going to add the 10, take away the 5. And then what do? I minus the 6. I don't have enough beads to minus the 6. I know the partner of 6 is 4. So what do? I minus the 10 plus the 4. I minus the 10, minus the 10, and I add the 4. There's not enough to add the 4. This is the two-step. How do I add the 4? Plus 4 is equal to plus 5 minus 1. How do I know that? Because we teach the children how to make a 5. Smoke, still here. So we're going to plus the 5, take away the 1. So my final answer is 66. You could say, well, we could take this and we can just subtract 1. You could do that. You could do that. It's not a problem to do it. But then you don't practice the abacus. That's all. You could go through and find shortcuts. I'm late. How did you get 67 on the abacus? 67 on the abacus? Like, how do you know to move the specific blue bead? The blue bead is a value of 5. I am unfamiliar with an abacus. Yep, not a problem. The top bead will always be 5. If that's okay, Ryan. I'm happy you came in and saw the interest in it. I would be surprised that if you're here and you know how to use the abacus, because this is the introduction to abacus. So, what are we doing? Maybe they're asking about place columns. Well, okay, yes, glee bow, yes. But the first thing we can do is understand how to read the abacus. So we have 1, 2, 3, 4. This is 4. Every time the beads are touching this horizontal bar, this is 4. So then we have 5. The 5 will always be, the top bead will always be 5. Check out her page. Oh, thank you, Monty. So 5 will always be 5. The top bead will always be 5. Because this is 5, we have 6, 7, 8, 9. And so what Glee Bao was talking about was our place values. We have our ones, tens, hundreds, thousands, and 10,000. So if I want to do 10, that's what 10 looks like. And then after 10 is 11. After 11 is 12. After 12 is 13. So what we're doing is every column has only number 9. So if I did this, this is 9. This is 93. If I did this, this is 993. If I did this, this is 999. 999. Does that make sense? So when you said 6, 7, this would be 60. This would be 7. Because I have my tens, which is a 6. I have my ones, it's the 7s. Yeah, you're welcome, dog. It was a very good question. It's a very good question. So then if you notice, I have this dot indicator. There's a dot right here. This is where my ones is. I could choose this one like a Pokemon. I could choose that, right? But then I don't have any more hundreds here. Ones, tens, no hundreds. However, if I choose this one, right, it makes sense. I didn't know each column represented a set of numbers. Yeah, I would do, yeah, tens and sets. Yep. So it all depends. Now, the question would be, well, what happens if there's more numbers? Well, if there's more numbers, you just get a bigger abacus because size matters. Crack myself up. I have all these jokes. I got jokes. So this is a 13 column abacus. This is a 7 column abacus. So what's going to happen is if I only go to 10,000. TikTok, everybody needs to be on. This is the. So then I made something that made it more. There we go. There we go. So we have our ones, our tens, our hundreds, our thousands. Notice there's another dot here. This is a group indicator. This is a group separator, right? So then we have our ones, tens, hundred, thousands, 10,000, 100,000, millions. Oh, there's another dot right there. Hey, Melinda, welcome back. After the what millions, 10 million, 100 million, billions, right? This is billions. Notice that there's another group separator. So then billions, 10 billion, 100 billion, trillions, right? But after trillions, you can't start. But if you wanted to, you could start here. It would just be ones, tens, hundred, thousands. Then this would be decimals over here. This would be decimals. I didn't type it out. I just didn't do it. However, if you wanted to track the national debt, you would need a bigger abacus. You need a 23 column abacus to track the national debt. And it'd be the same. Ones, thousands, millions, billions, trillions, quadrillions, quintillions. Thank you. In 10, 15 minutes, I've been here. You've taught me so much. I have to go. Thank you, Glebao. Thank you. Thank you. Thank you. I appreciate your help with Willie Nelson. Willie Nelson. Now I gotta go listen to some Willie Nelson. Thank you, Melinda. Okay. How is the questions? Anybody have a questions? That boy ain't right. I get it. Yeah. It's okay. It's okay. Propane. That's funny. Uh, it's fine. It's fine. At least, thank you. Yeah, you have a good day, and I hope to see you in my next live. We can go into adding, subtracting, multiplication, division, but now we're just going to stop at adding and subtracting. Thank you for the follow, dog. Thank you for the follow, Glebao. Yes, thank you. Okay. Is there any more questions? Any questions? So that was the thing, is like understanding the place values. And we can, it's the same thing. So this is made out of bamboo, and I've had this one for 20 plus years. I've been teaching abacus for 20 plus years. This one is in my TikTok shop. This one is made out of plastic, and it's very easy to move. So be careful. It's very easy to move, but it's also standard size. So if you have big burly hands, you could still use it. Big burly hands, because why? When you look, we have edges on the beads, and these is where you become very gentle. You want to be gentle with the beads. You don't want to be aggressive. We want to be happy when we do math. We want to be happy when you do math. Hey, Jose. So when we look at it, right, we do 1, 2, 3, 4. Notice I'm gently, very gently moving the beads. So when we do it, right, we have 1, 2, 3, 4. Anytime the beads are touching the horizontal bar is being counted. We have 4. This is the top bead. The top bead is the 5. Why is it a top bead? That's just the way it is. If you want to be poetic, you could be heaven beads and earth beads. Anything above the horizontal bar is the heaven beads. Anything below the horizontal bar is the earth beads. So when we read it, we have 1, 2, 3, 4. After 4, we have 5. Because this is 5, we have 6, 7, 8, 9. And after 9, we have 10. Right. So when we look, we can match it up. Every column is a place value. Ones, tens, hundreds, thousands, 10,000. Start from the bottom, like right to left. That is 10. Yes, this is 10. Yes, this is 10. So when we're reading it, this is 9. 5, 6, 7, 8, 9. Right? This is 8. 5, 6, 7, 8. Right? 5, 6, 7, 8. So when we do 8, we have 5, 6, 7, 8. Mitch says, can you show something simple like 5 plus 5? Yes, that'd be 10. So the first dot on the left is thousands. It can be, or it can be ones. It just matters of whether or not you can, um, whether or not you can, how big you want your numbers to be. So if I choose this to be my ones, then I don't have any hundreds. If I chose this to be my ones, if I chose this dot to be my ones, then it would be over here. So Mitch, before we go, doing a 5 plus 5, we need to understand how to make a 5, how to make a 10. That's why. So we can do adding, but there's some steps that we need to follow, if that makes sense. So the first thing we need to do is understand how to make a 10. No, the first thing we need to do is understand how to make a 5. The reason why we need to make a 5 is because this is what they're teaching children, and notice that we are not utilizing it to its fullest potential. So, going back to Raul, so the first dot on the left is thousands. It can be. Or if we do this one, right, the first dot could be billions. It doesn't matter. It depends on it depends on which dot we're in, right? So if we did this one, it would go like that. It'd be ones, tens, hundred, thousands. If we did ones here, so it's always about the dot. So we do the ones, thousands, millions. If we chose this one, it'd be ones, thousands, millions, billions. Does that make sense, Rahul? So when we look at it, it all depends on what number you're looking at. Yeah. Yeah. So it's all, like a Pokemon, right? Like a Pokemon. You choose whatever Pokemon to fight for you. So it's the same thing with the abacus. It's the same thing with this one. It doesn't matter how big the abacus is, it just matters how. Oh good, Mitch. Oh good. Yeah, I want to talk about the 5 plus 5, but we have to know our formulas first, and we're not there right now. Right now, we're trying to understand how to read the abacus. So this is a longer, this is a lot bigger, right? So this is the ones, or you could choose the ones here. I usually, if it's a bigger abacus, I usually start in the middle. So again, we can do 1, 2, 3, 4, and then 5. 5, 6, 7, 8, 9, and then 10. Yeah, yeah. I, I mean, I could show you the easiest one, which is 2 plus another 2. Why? Because I have enough beads to add the 2. The biggest question is do I have enough beads to add the 2? Yes. So I'm going to add the 2. I could do 5 and then I could add the 4. Is there enough beads to add the 4? Yes, I can add the 4. So there's a framework to understanding how to add and subtract on the abacus. There's a framework. Because we have a framework, that's why I don't go ahead uh too fast. Because when I start going ahead, um, people get confused. So there's two sets of numbers, two sets of formulas we need to understand. One set is how to make a 5. The next set is how to make a 10. So your specific question was 5 plus 5 is equal to 10. But understanding the fundamental first would be the key. So the question would be, why do I need to use this? Well, when I do this is when I don't have enough beads. So if I have a question 4 and I want to add another 4, I don't do it. I tend to start on one side. It makes way more sense. I tend to start on one side. This makes way more sense. Oh, right. So here I want to add 4. My question is 4 plus 4. I've got books. Okay, 4 plus 4. Abacus world, we do not memorize doubles. We do not memorize the doubles. What we're going to do is we're going to understand the concept that we're teaching the children. We're teaching the children this concept 4 plus 1 is equal to 5. Why are we doing this? I don't know why. But it's very critical in abacus world. This is really cool. Because why? We can actually utilize the 5. If I have 4, what is this book called? Oh, it's right here. It's available here, or it's available on the other platform. And I can't say the other platform, but that's what it's called. And my name is Lynette Young. Hello, everybody. I'm an abacus teacher, and you can find my books everywhere. Yeah, thank you. So, what we're doing, oh, wait, what we're doing is this. The question is 4. I want to add another 4. We have this concept. Thank you, Eden. We have this concept. We're teaching the kids. We're teaching the kids this concept. But we're going to take it one step further. What does that mean? Well, we're going to go to here. We is what we call abacus formula. And that means we're going to utilize the 5 and utilize the 10. So we have these concepts that we're going to do is we're going to take this concept and we're going to do a little bit of algebra. Love maths. Thank you. So when we look at it, this is a little bit about algebra. We're going to isolate this variable. We're going to isolate the 4. Why are we going to isolate the 4? Because the question, we're looking at the add-in. We're not looking at the result. We're looking at the add-in. With the add-in, we want to be able to learn how to add the 5, take away the 1, right? We don't need to do number lines. We just need to understand this concept and know how to use it. So when we're going to add the 5 and take away the 1. So my final answer is 8. Does that make sense? We can do it again. Let's do it again. So I have 3. Again, we don't memorize our doubles. What we do memorize is a concept. We have three. I have three on my abacus. When I don't have enough beads to add the four, I'm adding the four. I'm not going to memorize what four is. I'm going to memorize my formula. I add the five and I take away the one. I add the five and I take away the one. Now this understanding how to make this four, how to the add in of the four now becomes more versatile. Thank you, Ma. We could do it again. So again, we're not doing doubles minus one. We're not doing doubles plus one. We're not learning that strategy. We're not memorizing that strategy. We're understanding the concept how to utilize a five. So we have four. I'm sorry, we have two. We want to add the four. Guess what? We know the concept. Plus the five minus the one. So I plus the five, I take away the one. And this is why it's critical to understand how to read the abacus. Thank you for the follow, Mitch. So this is what we do. We understand how to move the beads. We will know how to read the abacus. So my final answer is 6. Wow, thank you guys so much for the hearts. How are we doing? Does that make sense? So when we look, we don't memorize doubles. I don't know what else we have to memorize. There's a bunch of things we have to memorize. This is a concept that we're teaching the kids. What we're doing is in abacus world, we are making it more efficient, more versatile, more versatile. So what's going to happen? We could do 3. What? Yeah. So guess what? Look, if I do plus 4 is an add-in. We can do the same thing with the 3. What? We can't plus the 3. Well, yeah, we can. Because what do we do? Plus the 3 is what? To make a to make a 5, we do 5 plus 2 is equal to I'm sorry. 3 plus 2 is equal to 5. This is again another core concept we're teaching the kids. How do you make a 5? How do you make a 5? Right? We're not going to tell them to memorize 3 plus 3 is 6. We're not going to tell them that. What we're going to do is we're going to tell them, if I have a constraint, there's my 3. I want to add another 3. How do I do it? To add another 3, I have this concept. I'm going to make it 3 is equal to 5. That's not balanced. So I need to minus the 2. So on my abacus, I can add the 3, add the 5, minus the 2. My final answer is 6. Let's do it another way. What does that mean? Where did my... So I don't know where everybody is. Let's do this. I don't know where everybody's located, but let's talk about this. So if I have 3 cents, these are pennies. These are pennies, right? If these are pennies and I want to do an exchange, right? I want to add 4. Right? There's 3. I want to add 4. But guess what? I only have a nickel. I only have 5 cents. If I only have 5 cents, I'm going to give you 5 cents, but you have to give me change back. So I'm going to take this 1 back. That is how the abacus works. So my final answer is 7. So let's do that again. If I have 3, I have 3 on the abacus. I only have 5 cents, but it's worth 4. I'm adding 4. I only have 5 cents, right? I only have 1 nickel. What do? I'm going to give you my 5 cents, but you have to give me change back. So I'm going to give you my 5 cents, but I need change, and I take away the 1. So my final answer is 7. Thank you, mooncakes. Does that make sense? Okay. So what we're doing is we're just looking at, yes, but you're supposed to do 3, not 4. Oh, sorry. So if I did 3, even if I did 3, I give you 5 pennies. If I give you five and it's worth three, then I take away two, right? So then I get six. You should have, it should have been 4 pennies. Okay. I don't know what question I was supposed to do. This one or that one? I don't know what question I was doing. Sorry. Sorry for the confusion. Yeah. Okay, good. It's fine. Yeah, I don't remember what number I was doing. But I was trying to show how to make it with the five. Five. Eh. 5 plus 3. Is there enough? Well, what okay. Well, what is the question? Do you remember the question? Was it 3 and then plus another 3? So if I plus another 3, I only have 5 cents. So if I have 5 cents, I want to plus another 3. I'm going to give you my 3, but I have to get change back. So my answer is 6. Was the other one? If I had 4, we had 4. I only have 3. I want to give you 3, but I only have 5 nickels. So because I'm going to give you 5, I'm going to give you 5 cents. I need to get the change back, which is 2. Yeah, we're on the threes page. Oh, okay, yeah. So here, 4. I have 4. 1, 2, 3, 4. I want to add 3, but I only have a nickel. I only have 5 cents, right? If I only have 5 cents, but I need to add the 3. If I only have 5 cents, I need to add the 3. What do? I give you my 5. I'm going to give you the 5, but I need change back and I need to take 2 away. So I take 2 away. So my final answer is 7. Sorry. Right. Thank you. Yeah, I've been doing this for a little bit. It's time for me to head out. Yeah. I've been on for a while. So I think it's time for me to take a little break. Yeah, makes sense. It's all good. It's really cool. Okay, thank you. No, I appreciate that. No, I appreciate that because I don't want people to get confused, right? That's the problem. Like if you get confused, then it doesn't make any sense. But yeah, yeah, no, no, no. Thank you, Compy Bear. I do appreciate all the questions. But yeah, when I start making mistakes like that, that's when I know I need to like end the live. That's when I know I'm tired. Yeah. So, I mean, it's interesting on how everything is, and we could do the same thing with the three. Let's do the same thing with the three. Let's do this, right? Three, and again, we don't memorize doubles, right? What we're going to do is we're going to have three, and because we have three, I only have a nickel, right? I'm going to give you my nickel. I'm going to give you my 5 cents, but 5 cents is too much. I need change back, so I need to take away 2. That's what 3 plus 3 is. That's what 3 plus 3 is. Yeah, plus the 5 and take away the 2. Yeah. Excuse me. All right. If anybody else have any more other questions, I am going to sign off. I'm feeling the tiredness. Yes, thank you. Thank you everybody for joining. Wow, 13, 12. That's a fair amount. A fair amount of people. You guys are pretty cool learning this during the day. Thank you. Thank you, Chris. Thank you. You enjoy your day. I'll see you tomorrow. I'll see you tomorrow too, Compy Bear. You had to take a rest. Yeah, thank you. I appreciate it. Oh, thank you, Belinda. Thank you. Thank you, Fascio. Yo. Yeah. Maybe I'll go listen to some Willie Nelson. We had 50 earlier. Oh, yeah. Yeah, I saw that. I was like, woo, woo, I'll be around. Oh, good. Fantastic. Yeah, thank you for the follow. I'm on pretty often and we talk about abacus. So, and anytime you have any question, I know, oh, there was one person that was actually doing a paper on abacus. I'm like, whoa, let me know if you have any questions. I'll tell you whatever I know about abacus. It's the greatest, I think it's the greatest thing next to sliced bread. I have 3 boys and they all know how to use the abacus. I live vicariously through them. Do they like it? Kids don't like to learn, but I think it's the greatest thing because they don't know the difference between memorizing and understanding. And so I know that difference because I had to memorize and it was so hard. It was so difficult. I hate memorizing. But this, there's not a lot for you to memorize here. It's just a lot about how do you Tetris your way through. So, all right. Thank you, everybody. Thank you again, everybody, for joining. Let me know if you have any questions. I am going to try to build out my TikTok shop a little bit more. And I'll see you later. Hey, Neon Panther, I can't believe you're still here. I appreciate you. Thank you again. Thank you again, everybody. And if you have any questions, come with your multiplication arithmetic questions, and we'll go through it quickly. But yeah, we will go through and all of it. Okay. Have a good day, everybody. Have a good day, and I will see you guys all in my next live. Got to keep the views up. Yes. Thank you for the knowledge. Yes. Thank you so much. Thank you. Multiply tonight. We will try. It depends on the class. It all depends on the class. Sometimes we get all the way to division. Melinda knows. Neon Panther knows. It all depends on who shows up and how many people I piss off. Division tonight. I love it. All right. All right. Thank you again, everybody. Thank you for all your support and all your comments and questions. It was really good. Thank you, everybody. Thank you. Thank you. Have a good day. Have a good night. Have a good evening. Have a good morning. Bye. Oh.